Hello everyone, welcome to my channel Worldwide Tutoring. Today in this video, we'll see how to name cyclic and aromatic compounds. Cyclic compounds are the compounds, they form a closed cycle. Like for example, like 3 carbons in a closed cycle, they are called cyclopropane. 4 carbons forming a closed cycle, they are called cyclobutane. 5 carbons in a closed cycle, they are called cyclopentane, and 6 carbons in a closed cycle, they form cyclohexane. And if there are 7 carbons, cyclohexane, and so on. In the cycle, they may also contain double bond or triple bond. So then becomes the suffix becomes "ene", cyclopentene, cyclohexene. For example, here, 3 carbons in a closed cycle with a double bond is called cyclopropene. 4 carbons in a closed cycle with a double bond here is called cyclobutene. So "ene" means represents double bond and cyclo because they are in a closed cycle. Cyclic hydrocarbons are also found in biological molecules like cholesterol, steroid hormones like testosterone, estrogen. So these compounds, this structure and these compounds are also present in these biological molecules. Now, naming of these compounds. Cyclic compounds are named. The root is the number of carbon atom in a cycle, that is called root, like 5 carbons in a cycle. So root is cyclopentane. For example, here 5 carbons in a cycle and there is a methyl group attached. So we call it methyl cyclopentane. So the name will be methyl cyclopentane. Cyclopentane is the root and methyl is a side chain. So methyl cyclopentane. Similarly, the next one, there are 6 carbons in a closed cycle, so it is cyclohexane, and there is a methyl group side chain attached, so it's called methyl cyclohexane. Here again, in a closed cycle, there are 6 carbons, but 2 different groups are attached. One is methyl and ethyl. So first we name ethyl, so we number this one, carbon 1, and the next will be 2 and 3. So 1 ethyl, 3 methyl cyclohexane. So 1 ethyl, 2 methyl cyclohexane. In this compound, there are 5 carbons in a closed cycle, but there is a double bond here. So we name this carbon 1 and this 2, and we number from where the double bond starts. Okay, either you can go this way clockwise or counterclockwise. So it is called cyclopentene. Cyclopentene. Next, in this, there are 7 carbons in a closed cycle. So this is cyclo, but there is a double bond here. So cycloheptene. Hepta means 7 carbons. So there is a double bond here. So we give preference to double bond. So numbering is done. So carbon 1, 2, 3, 4, and 5. On 5th carbon, there is a methyl attached. So it is 5-methyl cycloheptene. So 5-methyl cycloheptene. Suppose this name is given, to write structure, how will you write? So cyclo means in a closed cycle, heptene means, hepta means 7, ene represents there's a double bond. So we draw 1, 2, 3, 4, 5, 6, 7. So anywhere you put double bond, so there's a double bond. Okay, so this becomes carbon 1. This is 2, 3, 4, 5. So here 5-methyl. So methyl group is attached. So you can write here CH3. So this is 5-methyl cycloheptene. Okay, next compound we'll go to. So this cyclic compound, they can also form side chain. For example, in this So there is a long chain of how many carbons? 1, 2, 3, 4, 5, 6, 7, 8 carbons. So it's octane. All single bonds in the main chain, so octane. On third carbon, there is a branch of cyclopentane. So this is 1, 2, 3, 4, 5, 6, 7, 8. So on third carbon, there is a side chain of cyclopentane. So we call it YL, cyclopental. All the side chains are called YL, like ethyl, methyl, propyl. So cyclopental octane. So it is called 3-cyclopental. So YL is attached for all side chains. So 3-cyclopental octane. Okay. So now the structures will be given. You have to draw structures, names given. So how will you write this one? So methyl cyclobutane. So cyclo in a closed cycle, there are 4 carbons and there is a methyl attached. So we can draw this is cyclobutane and there is a methyl attached. This is a line structure. Okay. Or if you write other structure, then CH2, 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 and one of the hydrogen is replaced. So we have to remove one hydrogen. It becomes CH and CH3. Next is 1,2-dimethyl cyclohexane. So cyclohexane means 6 carbons in a closed cycle. This is cyclohexane. So 1,2-dimethyl. So anywhere you can start one carbon 1 and this will be 2. If this is 1, this will be 2. So 1,2-dimethyl. So there is one methyl here and another methyl here. So 1,2-dimethyl cyclohexane. Third is 3-methyl cyclopentene. So number 3, cyclopentene, 5 carbons in a closed cycle. And ene represent there is a double bond. So somewhere you put double bond here. Okay. So this becomes carbon 1 and carbon 2. And 3 and 4 and 5. Now place the group 3-methyl. So on third group there is a methyl. So methyl means CH3. So 3-methyl cyclopentene. Number 4, 2-ethyl 3-propyl cyclohexene. So ene means there is a double bond. So draw number 4 here. So cyclohexene first we make 6 carbons in a closed cycle and there should be double bond. So we put double bond anywhere. So you can draw a double bond here. So this becomes carbon 1, 2, 3, 4, 5 and 6. Now what are the groups attached to ethyl? On second carbon there is a ethyl here, C2H5, 3-propyl. So on third carbon there is a propyl. Propyl means 3C3H7. Or you can write CH carbon 3 times CH2, CH2, CH3. Also you can write. 2-cyclobutyl pentane. So pentane means 5 carbons. So we draw pentane 1, 2, 3, 4, 5. And 2, we number them 1, 2, 3, 4, 5. So this is pentane. Okay, 2-cyclobutyl. So on second carbon, cyclobutyl means in a closed cycle there are 4 carbons and they are attached here. So how will you draw this? Okay, so 4 carbons in a closed cycle. This is called cyclobutyl pentane. Okay, next we'll go to. But they like this we name cyclic compounds. Now we'll go to aromatic compound. They are aromatic hydrocarbons. They are called also known as arenes. So aromatic hydrocarbons, they contain benzene ring. So all aromatic compounds, they have benzene ring. And this compound, they have very strong aroma. So they are called aromatic. And one of the main reason for aromatic is they burn with the sooty flame. If you take aromatic compound and burn it, for example, like a solution aromatic compound is given, just take a glass rod, dip in it, and just bring near the flame. So this is a flame. So then you will see a sooty black, sooty flame will be coming out. So that indicates it is an aromatic compound. So all aromatic compounds, they burn with black sooty flame. Okay, how to name them? So benzene is C6H6 molecular formula. There are 6 carbons and 6 hydrogens. They are attached in a close ring with alternate double and single bond. So here's a double bond, next is single bond, then double bond, then single bond and double bond. So there are 3 alternate double and single bonds. And in these two structures are resonating structure, they are interchanging. It means this double bond is formed between these two carbon. Immediately then it changes to now single bond develops here. There was a single bond, then here develops double bond. This is because the electrons, the pi electrons here are delocalized. So they are moving from one between two carbon to next carbon. So they are delocalized. That makes the benzene ring very stable and both the structures are interchanging. So we write benzene ring with the circle inside. So this is called resonance hybrid. Okay. So this structure also represents both of them are interchanging. So we represent by this structure for benzene. So benzene we make a ring and circle in the middle. So that is called resonating hybrid. Okay. So now naming aromatic compounds. All aromatic compound, they contain benzene ring. So root is benzene. We have to say benzene and tell the groups, whatever groups attach. For example, here methyl group is attached. So it is called methyl benzene. So methyl benzene. And a common name also known as toluene. Some common names are also you should know. They are very common. So they are called toluene. Toluene means methyl benzene. When chlorine group is attached to benzene, is called chlorobenzene. Chlorobenzene. Now here two different groups are attached. One is ethyl and methyl group. So when we name ethyl first, alphabetically it comes first. So ethyl is carbon 1, then 2 and 3, 4, 5, 6. 4, 5, 6. So 1 ethyl, 3 methyl benzene. So 1 ethyl, 3 methyl benzene. So in this group, now benzene ring, and there are 2 ethyl groups attached. So this is 1, 2, 3. So we can say 1, 3 diethyl benzene. So 1, 3 diethyl benzene. You can draw like this. In benzene ring, there are 2 methyl groups attached at 1 and 4 positions. So this is 1, 2, 3, 4. So 1, 4 dimethyl benzene. So this compound is 1, 4 dimethyl benzene. Next one, there is a nitro group attached to benzene. It's called nitrobenzene. Benzene ring can also form a side chain. For example, in this, so there's a long carbon chain of 1, 2, 3, 4, 5, 6 carbons. And benzene ring is attached on third carbon. So all the side chain, they're named as YL. So we phenyl, it's called phenyl. So 3-phenyl hexane. 3-phenyl hexane. So like methyl, ethyl, propyl. So this is called phenyl. So phenyl means when the ring is attached to benzene ring attached to side chain. For example, here, so there's a long carbon chain 1, 2, 3, 4, 5, 6, 7, 8 carbon. So it's octane. And these rings are attached on second carbon, third, and fourth. So 2,4 diphenyl octane. So 2,4 diphenyl octane. Benzene naming in these compounds, sometimes the names are given in this form: ortho, meta, and para. So ortho positions are called 1 and 2, or 2 and 4 positions are called ortho. This 2 position and 4 position. Suppose methyl is the first group or first position, then this will be second, third, fourth, sorry, 1, 2, 3, 4, 5, 6. So for this methyl group, this is the second position. 1, 2, 3, 4 position. This is 4 position. So this is called ortho group. Okay, either CH3 here, or on fourth position any group attached adjacent to this. If there is a methyl, next one, or this on the other side also this group. So this is called 2 and 4 positions. So they are called ortho positions. Meta position 1 and 3 position. So this is 1. Then third position is this, or also this 5 position. Okay, 1, 3 or 1, 5, 3 and 5 position, they are called meta positions. 1 and 4 positions are called para positions. So any group attached here, and the fourth position again another group, so it's called para position. So you can IUPAC name is, we say 1,2-dimethylbenzene. Okay, so 1,2-dimethylbenzene. Or you can also say ortho-dimethylbenzene, because they are two adjacent group, 1 and 2, so also known as ortho-dimethylbenzene or ortho-dimethylbenzene. So IUPAC name for this one is 1,3-dimethylbenzene. How will you name them in terms of meta? Meta-dimethylbenzene. So also known as meta, we can write in short dimethylbenzene. M for meta, dimethylbenzene. 1 and 4 position, they are called para. So IUPAC name is 1,4-dimethylbenzene. Or in terms of para, you can say 1 or just para-dimethylbenzene. So para means we write just P, dimethylbenzene. Okay, another compound. This is methyl, it is toluene. CH3 group attached to benzene is called methylbenzene. And also common name is toluene. So when 3 nitro groups attach, it is called trinitrotoluene. So it is the explosive product. So it is called trinitrotoluene. So 1 nitro here, that is 2, 3, 4, 5, 6. IUPAC name will be 2,4,6 trinitrotoluene. So 2,4,6 trinitrotoluene. Okay, some names given. You have to draw structures. So first one is 1,2,4 trimethylbenzene. So how will you write this one? 1,2,4 trimethylbenzene. So first draw benzene. So this is one, anywhere you can start 1. So this is 1 position, 2, 3, 4. This is 4. And also 2, 1, 2, 4. 1, 2, and 4. So trimethyl, there are 3 methyls. So 1 methyl here, second, and third. Okay, next one, 1-ethyl 2-methylbenzene. So 1-ethyl 2-methylbenzene. So draw benzene first. So 1-ethyl, so C2H5, 2-methyl. Here is methyl CH3 benzene. Number third, 3-phenyl octane. Octane means 8 carbons. We have to make 1, 2, 3, 4, 5, 6, 7, 8. And 3-phenyl. So this is carbon 1, 2, and 3. The third group, there is a phenyl attached. Phenyl means benzene ring in a side chain. Okay. Ortho, see, we write O for ortho, or means 1 or 2 position. Ortho diethyl benzene. So ortho means 1 or 2 position. So this is benzene ring. The one position diethyl. So ethyl group C2H5 here and another C2H5. So they are called ortho position, this and this position. Okay. Para, P for para ethyl methyl benzene. So number 5, the first draw benzene ring. Para is 1 and 4 positions of para. So para ethyl methyl benzene. So right here methyl and here ethyl. So IUPAC name is 1-ethyl 4-methylbenzene. But in terms of para means 1 and 4 positions are called para. So para-ethyl methylbenzene. 1-ethyl 2,4-dimethylbenzene. So how will you write this one? So the first draw benzene ring. 1-ethyl, so anywhere you can write ethyl, so that becomes carbon number 1. 2,4-dimethyl. So this is 1, then this will be 2 methyl group and 4. So this 2, 3, and 4. This is the 4th position. So 1-ethyl 2,4-dimethylbenzene. This is 2 and 3 and 4. And next one. Okay, 1 minute. 2-phenyl butane. So 2-phenyl butane, phenyl is side chain. So butane means 4 carbons. So make 4 carbons. So CH3, CH3. 2-phenyl. So here phenyl group attached. H and CH2. So 2-phenyl butane. So I hope you like this video. If you like, please like and subscribe to our channel. Thank you.